In this video, we are going to learn how to write polynomial functions given their zeros, their roots, or their x-intercepts. So there's a few theorems that are going to be helpful for us as we do this. The fundamental theorem of algebra tells us that whatever the degree of the polynomial is, that's how many zeros we should have. So that'll be very helpful. We also have the complex conjugate roots theorem, which basically is if I have a root a plus bi, I will also have a minus bi. They always come in pairs. They are never alone. And the same goes for your irrational roots. They also come in pairs. We call them conjugate pairs, but pairs is perfectly fine. They come in pairs. Never travel alone. So let's get started. We are going to write a polynomial function that has a degree of 3, has a 0 at 1 and at 7i. So right away, we know that we have to have a conjugate for 7i. Okay, so the conjugate for that is minus or negative 7i. Now I have all my 3 zeros, right? The degree is 3, so that means I have to have 1, 2, 3 zeros. I have all 3. So now I can write this beginning in factored form, but we should know how to write these in standard form eventually. So let's begin. I'll have x minus 1 for the first 0 of 1. I'll have x minus 7i from the positive 7i. And then I'll have x minus negative 7i, which is really plus 7i. So that's from the negative 7i. Now it's time to multiply. Whenever you are writing these in standard form, it is wise to multiply the conjugate pair together first. And I think you will see why in a moment. So I'm going to leave x minus 1 over to the side. When I start to multiply, x times x, I get x squared. X times 7i, that's plus 7xi. Then I start moving on to my next term. I have negative 7i multiplied by x, which is minus 7xi. And then I multiply negative 7i times positive 7i, so that's minus 49i squared. The beauty of conjugates is that when multiplied together, the middle terms that you end up with add to 0, or they cancel out, however you want to describe it. So now I still have that x minus 1 out front, but when I simplify this, I have x squared. Let's go ahead and simplify this minus 49i squared. If you remember, I squared is the square root of negative 1 squared. Remember that I is the square root of negative 1. So if I square I, then that would be the square root of negative 1 squared. And if I square a square root, well, that cancels out the square root. So I squared is actually equal to negative 1. So I have this I squared here, but it's actually going to be negative 49 times negative 1, which is plus 49. That is way better. No more i's left. I just have 2 binomials that I need to multiply together. So I'm going to go ahead and do that. I'll do x times x squared. I get x cubed. X times 49 plus 49x. I have negative 1 times x squared minus x squared. Negative 1 times 49 minus 49. Now rewrite it in descending order. So highest exponent first, then the next highest, then the next highest, and then your constants if you have any. There's our final answer. We've got a polynomial in standard form. Okay, let's do this again. So now we have a 4th degree polynomial. So that means it has 4 factors or 4 zeros, and we only have 3 listed. We have 6, 0, the square root of 3, which means that we should have a conjugate pair with this, and the pair would be negative square root of 3. So we're ready to write these into factored form. I'll have x minus 6, x minus 0, which is really just x, so we'll simplify that in a second, x minus the square root of 3, and x plus the square root of 3, or minus negative root 3, so plus. Okay, this x minus 0 is just x, and I'm going to write that out front. And then I have x minus 6. Now, like I said before, you want to start by multiplying the conjugates together first. So I'm going to do x minus root 3 times x plus root 3 first. X times x is x squared. X times root 3 plus root 3x. Okay, negative root 3 times x minus root 3x. Negative root 3 times positive root 3 is minus root 9, which is 3. So we'll simplify that in a sec. That's just 3, or minus 3. Okay, I'm going to go ahead and multiply this x as well. So I have x times x is x squared. X times 6 minus 6x. Okay. So let's write this. Oh, look at that. Plus root 3x minus root 3x. That's 0. So I have x squared, and this became minus 3. Yay! Once again, we just have two binomials that we need to multiply out. Okay, so let's do it. X squared times x squared is x to the 4th. X squared times minus 3, minus 3x squared. Minus 6x times x squared, minus 6x cubed. And minus 6x times minus 3 plus 18x. Okay, so let's rewrite this in descending order. X to the 4th will be first, then minus 6x cubed, then minus 3x squared, then plus 18x. No constants in this case. And there is our polynomial in standard form. Okay, let's try one more. Okay, so we've been asked to write a 4th degree polynomial function, so that means we should have 4 zeros. It's got a 0 at negative 4. Ooh, with a multiplicity of 2. So that basically means we have it twice, or it's squared, so I'll show you. And then we also have a 0 at 2 minus I, so we have a complex 0, which means we should also have a 0 at 2 plus I. Okay, so let's start writing this out. I have a 0 at negative 4 with a multiplicity of 2. So I have x plus 4 squared, or x plus 4 times x plus 4, right? That's what multiplicity of 2 means. We have it twice. Then I have x minus 2 minus I, and then I'll have x minus 2 plus I. Okay, so I'm going to make sure that I don't forget any negatives. I still have my x squared, my x plus 4 squared. And then I have x minus 2 plus I, right? Just distributing my negative here. And then in my next set, x minus 2 minus I. So now it's time to multiply those conjugate zeros together. Again, I'm going to wait to do the x plus 4 squared until afterwards. Okay, so here we go. I have x, right? I have 3 terms I'm going to multiply a lot of times. So x times x is x squared, x times negative 2 minus 2x, x times negative I minus xi, next term. Negative 2 times x minus 2x, negative 2 times negative 2 plus 4, negative 2 times negative I plus 2i. And now the final term, I times everything, I times x, so plus xi, I times negative 2 minus 2i, I times negative I minus I squared. Okay, there's a lot of terms in there, and a lot of them are going to cancel out. So we have a negative xi and a positive xi. Yay, they add to 0. We have a plus 2i and a minus 2i. Yay, adds to 0. Ooh, how exciting. Okay, don't forget, we know I squared is negative 1, so that means negative I squared has to be positive 1. So this is going to turn into a plus 1. All right, x plus 4 squared, I'll multiply that in a moment. I have in leftover from our lots of multiplication, we have x squared. I have a minus 2x and a minus 2x, so minus 4x. I have a plus 4 and that plus 1 from the negative I squared, so plus 5. Okay, that is much more manageable, but we're still not done yet because I still need to multiply out my x plus 4 times x plus 4. And I have my x squared minus 4x plus 5 that will get multiplied in a moment. So I'm going to go ahead and multiply these two together. X times x is x squared. X times 4 plus 4x, 4 times x plus 4x, 4 times 4 plus 16. Okay, let's combine like terms. I'll have x squared plus 8x plus 16 times x squared minus 4x plus 5. Okay, we are almost there. We just need to multiply these two trinomials together and then we will finally have it in standard form. So let's begin. We will have x squared times x squared, which is x to the 4th, x squared times negative 4x minus 4x cubed. X squared times 5 plus 5x squared. All right. Now let's do the 8x. 8x times x squared plus 8x cubed. 8x times negative 4x minus 32x squared. 8x times 5 plus 40x. One more term to multiply. Here we go. 16 times x squared plus 16x squared. 16 times negative 4x minus 64x, and 16 times 5 is 80. Let's find our like terms and write this in standard form. So highest exponent first, we have x to the power of 4. I have a minus 4x cubed and a plus 8x cubed, so I get plus 4x cubed. I have a 5x squared, a negative 32x squared, and a 16x squared. Add those all up together and we get minus 27x squared. I've got a 40x and a 64x. Add those together. That's minus 24x. And the cherry on top, plus 80. And we have finally gotten this polynomial written in standard form. Thanks for watching.